Hello everyone. Today I will be demoing direct server return functionality on Kubernetes platform. Here is the agenda. We will be talking about DSR and its challenges in Kubernetes platform. Why DSR is required and the solution provided by Citrix, followed by the demo and the advantages. What is DSR? DSR means direct server return. So when a client wants to access an application, the request first land on the ADC. ADC does the server load balancing and choose one of the server and sends the packet as it is to the server. Server will process the packet and send the response directly to the client. So to get this kind of DSR deployment, a certain set of special configuration has to be made at ADC and server. The server side configuration has to be present across all the servers. What are the challenges in Kubernetes? The biggest challenge in Kubernetes is about how to establish a network connection between ADC and service. So if you notice here, there are three levels of network is involved. The ADC network, then the node network, which is for the Kubernetes cluster management, and the pod network, which is for the actual application. So when a request comes on the ADC, it comes to the ADC network. Then we have to carry this ADC network or the public IP till the pod network where the actual application is running. So this is very challenging Kubernetes environment. The second challenge is about how to configure LB VPON servers. So this set of configuration has to be made across on all the pods. Since pod having dynamic nature and this set of configuration is depends on the tier 1 configuration or the ADC network, it has become very difficult for an admin to do this kind of configuration at pod level. The last challenge is about how to automate DSR kind of configuration on the ADC. Since the pods are having dynamic nature, manually configuring these things on the ADC is not feasible. So we should have a mechanism to automate DSR specific configuration on the ADC network. Why DSR is required? It provides a very fast load balancing mode. It highly used across video services because if you see video service, the request packet size will be very small and the response size will be very high. So the response can be directly sent to the client. And for few customers, they want to track the client information at service itself. And there won't be any bottleneck due to load balancer. Here is the solution provided by Citrix, which addresses all the challenges which we have discussed earlier. Citrix uses a two-tier topology. The first tier holds the DSR configuration and the second tier does the actual load balancing and sends the response directly to the client. Let's see how the packet flow happens across this topology. Let's say the client wants to access the application. When it wants to access the application, it uses SIP as the source IP and the VIP as the destination IP, which is hosted on the ADC. When this packet reaches to the ADC, it does the load balancing and choose one of the servers and adds two layers of information. The outer layer is about how to reach the node, which is based on the VXLAN tunnel. And the inner layer is about how to reach the pod, which is based on IP tunnel. Once the packet reaches to the node, it decapsulates the outer header and get the inner packet, which it sends to the CPX pod. CPX will pick up this packet and decapsulate it again and get the original packet. Based on this original packet, it does actual load balancing and sends the packet to the pod. And the pod will send the response back to the CPX. CPX will pick up this packet and send its response directly to the client. Let's see the demo. So this is my Kubernetes master node. It is a 2-node cluster. We are going to deploy a guestbook application here. First we are going to create a namespace. Then we are going to deploy the guestbook application on that namespace. Now we are going to create a tier 2 CPX. Next we are going to create the CNC for establishing a network between ADC and the cluster. Then next we are going to deploy the Citrix Ingress controller to configure the tier 1 ADC with the DSR configuration. So all the applications are up and running. Now let's see what all are the configuration present in the tier 1 and tier 2. So this is my tier 1 ADC where there is no application is hosted. Now we are going to create a DSR configuration for the tier 1. Now you see this ingress. Here we are using a front-end IP annotation which is used for exposing the application, and we are giving here the deployment as DSR. Okay, let's see, is the configuration pushed to the tier 1 ADC or not? Yeah, the configuration is pushed and it is up and running. Now let's see any configuration present in the tier 2. We will be connecting to the CPX and we will be checking any CSV server configuration present in the CPX or not. There is no configuration. Now let's expose the guestbook application route to the CPX. For that we are using this ingress YAML. If you observe here, the front-end IP which we are configuring or providing here is same as what we given for the tier 1. So both the ADCs having the same IP. We are going to deploy this ingress YAML. So now if you go and see the configuration on the CPX, we can see the application is created and it's up and running. Now let's access the application. So the application is accessible. We can do a test with this application. We can easily verify by checking the status in the tier 1 load balancer. If you see the stats here, you can see the request bytes are going through the tier 1, but there is no response byte on the tier 1 ADC. That's the demo part. So if you see, all the challenges which we have discussed earlier are addressed by Citrix, which reduces the burden on admin, and it provides a very fast load balancing. For the reference, you can go through this GitHub page. All the resources used in this demo are given in this repository, which can be used for further experiments. Thanks for watching this video.